Hmm? Yes, okay. So, good. So, let me carry on. So, what we are talking about is we are talking about the mole concept. The mole concept says that suppose any reaction N2 plus 3H2 gives you 2NH3. What we have to understand is what the mole concept says is that 1 mole of N2 reacts with 3 moles of H2 to form 2 moles of NH3. Do all of you understand this? Do all of you understand what is 1 mole? 1 mole of a substance is that weight which contains Avogadro number of molecules. Okay. So, do all of you understand this? Okay. So, now if you understand this, then let's move on. Now, what you can do from here is you can work either in weight or you can work in volume. Whenever gases are involved, you can work with volume and with weight. Whenever solids are involved, you can work only with solids. So, are we able to understand this? So, now here this is a gas, this is a gas, this is also a gas. So, now because they are all three gases, I can work either in weight terms or in volume terms. So, let me explain to you what is the weight term. In weight terms, what it means is the molecular weight of nitrogen, which is 14 into 2, 14 plus 14, because there are two nitrogens, it is 28 grams of nitrogen reacts with 6 grams of water, 6 grams of H2 to form NH3. N is 14 plus 3, 17. 2 into 17 is 34 grams of NH3. Understand 28 plus 6 is equal to 34. So I am going by the law of conservation of mass. Alternatively, what I can do is I can say that 1 mole of N2 is reacting with 3 moles of H2 to form 2 moles of NH3. But I know that 1 mole of a gas occupies 22.4 liters, that is Gay-Lussac's law. So 1 mole of N2 occupies 22.4 liters. So 3 moles of H2 will occupy 3 into 22.4 liters. And that will give me 2 into 22.4 liters of NH3. This I can do only with gases. Are we able to understand this statement? So, if you are able to understand this statement, then let me explain this to you once again. What I am saying is, suppose I have C plus O2 gives you CO2. See, this is a solid, this is a gas, this is a gas. In solid, I can work only with weight. But with gases, I can work with weight and I can work with volume. With gases, I can work with again weight with volume. So I can say that 12 grams of carbon gives me 44 grams of carbon dioxide. Or I can say that 12 grams of carbon gives me 22.4 liters of carbon dioxide. Both of them are the right approach. So here I am talking about grams, here I am talking about volume. Only thing that you need to understand is that all these calculations are done at STP, because only at STP can 44 grams of carbon dioxide occupy 22.4 liters. Are we able to understand? So now if you guys are getting it, I'll give you some questions based on this. So let's write down some weight of carbon requires 5.6 liters of oxygen for complete combustion. What is the weight of carbon? Hmm? Some weight of carbon requires 5.6 liters of oxygen for complete combustion. What is the weight of carbon? Huh? What is this? 176 grams. No. What are you doing? See, I have 22.4 liters. 22.4 liters is 1 mole. Now I have 5.6 liters. So how many moles is that? 5.6 divided by 22.4. That is how much? 1 upon 4. So I have 1 by 4 moles of oxygen. Yeah. So I have 1 by 4 moles of carbon. So that is 1 by 4 into 12. So that is 3 grams. Do you guys understand? Roshan, you guys answer one question. One simple question. Suppose to make 3 liters of sambar, I need, let us say, some 40 grams of salt. And suppose I need 4 liters of water. And suppose I need 6 chow chows. Huh? Then if I have 2 chow chows, how many liters of sambar can I make? Okay, if it's a careless mistake, it's fine. But anyway, since I've started, let me complete it. So if you have 2 chow chows, how many liters of sambar can you make? Huh? No. Assume you are working with ratio proportion. Of course, you decide not to put the chow chows in it. That's fine. So we can make 1 liter. Then how much of salt will you be using? So it will become 40 by 3 grams of salt you will be using. Plus how much of water will you be using? You will be using 4 by 3 liters of water. Okay, so it's simple. Whatever you are learning in mole concept, it's only ratio proportion. But from where do you get the ratios? Only from a balanced chemical equation. Okay, so small question for you. If I have 5.6 liters of hydrogen, how many liters of NH3 can I get if I have adequate N2? Answer this question. Give one answer. Let it be correct. Hariharan, you wait for some time. Let them reply. Then you answer. But do and sit. Yes, what's the answer? Okay, so let me see. So the first step, Rishi, is to write a balanced chemical equation. So I have N2 plus 3H2 gives you 2NH3, right? So now if I have 1 mole of N2, I require 3 moles of H2. That means I need 3 into 22.4 liters of H2. That will give me 2 into 22.4 liters of NH3. So 1 liter of H2 will give me 2 by 3 liters of NH3. So now I have how much? 5.6. So 5.6 will give me 5.6 into 2 by 3, that is 11.2 by 3, that is approximately 3.73. Hari, you have to be careful. There is no point coming out of the exam and then saying I knew but I made silly mistake. Okay. So, are you guys getting it now? It's always simple ratio proportion which comes from the balanced chemical equation, nothing else. Yeah, one answer you should give, it should be correct. That's it. You take as much time. That is not important right now. Speed will come later. First, accuracy. Okay. Roshan, are you getting it? Okay. Next question. Hurry, you wait. Let them answer, then you answer. Carbon burns in 5.6 liters of oxygen to form carbon monoxide. What is the volume of CO formed? Roshan, this is a very simple question. You should answer this without any pen, paper, nothing. Maybe just by writing the equation you should be able to say. Rishi? This is a solid, this is a gas, this is a gas. 1 mole gives you 1 mole. So 22.4 liters will give you 2 into 22.4 liters. So 5.6 liters will give you 11.2 liters. Okay. Yeah. So now you got it. So this is all the concept. Okay. Then let's move on. Answer this. 72 grams of water is electrolyzed. What is the volume of H2 formed? Okay, good. So all that you have to now do is understand that 18 grams is 1 mole. So 72 grams is 4 moles. 4 moles means, let me first write the balanced equation. H2 plus O2 gives me H2O. So 2H2 plus O2 gives me 2H2O. So 1 mole will give me 1 mole. So 4 moles will give me 4 moles. So it is 4 into 22.4, that is 89.6 liters. Good. Okay. So, is this concept understood? Can I assume it's understood? Yeah, so this is a very small part of this. If you understand that, it's very nice. Okay, next I'll explain to you this concept of equivalence. So, this concept of equivalence is very simple. So, now you understood the mole concept. Oh, but we will lose out of time. What to do? What to do? Okay, put it here and see me. Are you able to hear me now? Huh? Okay. So Uh, just a minute, huh? Just 1 second. Just 1 second. I'll get back to you. 1 second. Raja, I'll call you back in. Uh, so, so, see, the concept of equivalence is this. Suppose I look at this equation, CaO plus O2 gives me CaO. Now, can you tell me how this reaction takes place? Can I say that calcium has 2 electrons in outermost shell? Calcium gives these 2 electrons to oxygen. Then combustion, okay, but the mechanism for this reaction is calcium has a configuration 2 8 8 2. So these 2 electrons in the outermost shell, and oxygen has 2 electrons, oxygen has 6 electrons in outermost shell. So what happens is calcium gives these 2 electrons to oxygen, and you will have calcium will form +2, oxygen will form 2 minus, and they will come together to form calcium oxide. Huh? So when calcium reacts with oxygen to form CO2, sorry, CaO, I see that 2 electrons from calcium move to oxygen to form this. So if 1 mole of calcium is there, that 1 mole of calcium will react with 1 mole of, I have to balance it. So balance 2 doesn't come here, 2 comes here. 1 mole of calcium reacts, sorry, 2 moles of calcium reacts with 1 mole of oxygen to form CaO, to form 2 moles of CaO. Yeah. Now, if I look, 1 calcium gives 2 electrons. So 2 moles of calcium will give how many electrons? 4 moles of electrons. Now here 1 oxygen takes 2 electrons. So 1 mole of oxygen will take how many electrons? 4 moles of electrons. Do you see this? Do you see that the calcium is giving 4 moles of electrons and the oxygen is taking 4 moles of electrons, and then they are forming calcium oxide? Rishi, Roshan, do you guys understand this? Hari? Now, if you understand this, what I am now saying is, look, if you talk about electrons or moles of electrons, the ratio is 1:1. That means the weight of a substance which gives 1 mole of electrons reacts with another weight of, with the same weight of the other substance which gives 1 mole of electrons. Are you getting me? This is what is called as the law of equivalence. That is, one equivalent of a substance will react with one equivalent of another to form one equivalent of the third. And one equivalent of the substance is the weight of the substance which contains, which gives or takes or accepts or shares 1 mole of electrons. This is a very powerful definition. If you understand this, half of your chemistry is understood. One, we are saying that a chemical reaction takes place only because of sharing of electrons or donating of electrons, or it's basically an electron mechanism. So when it is an electron mechanism, you will realize that this happens. This is what is called as the principle of equivalence. One equivalent of any substance reacts with one equivalent of the second to form this. And one equivalent is nothing but, so let's see an example. So now I know H2 plus O2 gives me H2O. So I know that 2H2 plus O2 gives me 2H2O. So now hydrogen has 1 electron in the outermost shell. So these 2 hydrogens will require 2 electrons or can give 2 electrons. So they give 4 electrons. Oxygen takes 4 electrons. So 4 electrons of hydrogen, so it will be 1:1. That means, so oxygen is what? Oxygen has totally 32 grams. Now 32 grams of oxygen will give 4 electrons. So the weight of oxygen which gives 1 mole of electron will be 8 grams. So 1 equivalent of oxygen is 8 grams. And 1 equivalent of hydrogen is 4 grams by 4, that is 1 gram. So whenever hydrogen reacts with oxygen to form water, I can also say that 1 equivalent of hydrogen reacts with 1 equivalent of oxygen to form 1 equivalent of water. Okay, I am not sure if you are able to understand the link here. I'll just give you by an example. In the next class I'll do more problems on this, then we'll understand it better. Now suppose I make a statement. Let's look at a question. Some grams of calcium is burnt to form calcium oxide. The calcium oxide reacts with some grams of H2O to form calcium hydroxide, which reacts with some grams of sulfur dioxide to form calcium sulfate. With some grams of sulfur dioxide to form let's say H2SO4 to form calcium sulfate. Then let us say that this H2SO4 was formed from 8 grams of sulfur. What is the weight of calcium? So look here, A is giving B, B is giving C, C is come from D, D is again coming from somewhere else. So now when you work with the law of equivalence, you see how beautifully it will come. Now my starting point is this 8 grams of sulfur, because that's the only data that is given. So if I have 8 grams of sulfur, sulfur's atomic weight is 32. Okay. Now sulfur will take how many electrons? 2 electrons to complete its octet. So 32 grams of sulfur will require 2 moles of electrons. So for 1 mole of electron I need 16 grams of sulfur. So 16 grams of sulfur, but I have 8 grams of sulfur. So 8 grams of sulfur is half an equivalent of sulfur. Do you understand this? Half an equivalent. Yeah. Now the beauty of chemistry is this, that half an equivalent of sulfur will form half an equivalent of H2SO4. Half an equivalent of H2SO4 will react with half an equivalent of calcium hydroxide, which will again come from half an equivalent of calcium oxide, which will come from half an equivalent of calcium, which means that the amount of calcium that I have is only half an equivalent. Now calcium has an atomic weight of 40 and 1 calcium gives 2 electrons. So 40 grams will give me 2 moles of electrons. So for 1 mole of electron I need 20 grams. So now I have half an equivalent, that is half a mole. So how many grams of calcium will I need? I will need only 10 grams of calcium. So the answer is 10 grams. Do you understand? So this is how you can work very easily with equivalence. Remember that one equivalent of a substance is the weight of the substance which reacts, accepts 1 mole of electrons. There are a lot of other definitions available in books except for this definition. But if you remember this definition, you will see that you will be able to do the problems very easily when compared to any other method. Okay. I have shown you some very simple examples. I will show you some more complicated cases in the next class where you will really appreciate the concept of an equivalent. Okay. Yes, Hariharan has asked a good question. When I work with equivalence, it doesn't matter, Hari, because I am only working with electrons. So I am just, if I give 1 electron, you can take 1 electron, right? So now I don't need to balance. So the beauty of this is that I don't need to know what is the reaction. You see, when Tulsi was working, she was not able to proceed because she did not know the reaction. Now I don't care for the reaction. I just know that if there is a reaction, one half an equivalent will only react with half an equivalent. So if you work with equivalence, you don't need to know the reaction. You don't need to balance. You don't need to do anything. So that is what I was saying is the beauty, because in case of a complicated reaction, I may not know what the reaction is, but I'll still be able to do it this way. Okay. So good. So I will see you on Monday. We will work with more on stoichiometry or chemical calculations. Okay. Bye. Work hard and read well. Work with a target, work with a goal. Oh, so don't worry, you have the recording and subsequently message, Rishi, message to this number or mail it to me. So Rishi, message it to me, then I'll remember. Or send me an email, that is best. Okay, fine. Bye. Good night.